Hello students! Today we will talk about permutation. Permutation, by definition, is an arrangement in which order matters, or order is important. Okay, so how can I explain to you what order matters? Okay, so let's say, I want you now to differentiate order matters versus order doesn't matter. So let's try to differentiate what does it mean to have order matters. Okay, let's say I have 5 letters, A, B, C, D, and E. Okay, and we want to choose 3 letters out of it. So we want to get 3 letters, a set of 3 letters out of the set of 5. Okay, so let's say I want to choose B, D, and E. Okay, so order matters. B, D, and E. So this is the first set. So since order matters, the first one, the second one, and the third one matters too. So it matters who goes first, who goes second, and who goes third. Thus, we can also use the same letters, okay? B, E, D, okay? What else? We can have D, B, E, D, E, B. Okay? What else? We have E, B, D. Or we can also have E, D, B. Okay, so order matters. So it matters who goes first, what is the next letter, or what is the third letter. Okay, so order matters. Using BDE, choosing BDE, we have how many options? 1, 2, 3, 4, 5, and 6 options. When we say order, doesn't matter. So it doesn't matter who goes first, who goes second, who goes third. I just want to choose 3. Okay? So I only have B, D, E. Because in order, if order doesn't matter, these are all the same. Okay? So we have only 1. So if order doesn't matter, you can just arrange them in different ways. It doesn't matter, I just choose 3. Okay? If order matters, it matters who goes first, who goes second, and who goes next. Okay, that is what we mean order matters. Okay? So, let's move forward. Okay, so let's say I have 5 books here. Okay, so I have only 3 slots for my shelf. So I should choose 3 of them. So in how many ways can I choose 3 books to put in here? Okay, so I will choose 3. This is all about the permutation. Okay. Next. Okay. A permutation is an arrangement of n objects in a specific order using r objects at the same time or at a time. So in this case, n is the total number of possible selection or possible object to choose from. Okay? So in this case, I have 5 books. That's the total number. So this will be my n. Okay? Oops. This will be my n. Okay. Since I only can choose 3 at a time, because I only have 3, so this will be your r. Okay? So later on when we will talk about the formula for permutation, okay, so you have n and r. Okay, so the n is the total number of objects, and R is the number of objects that you choose from the total number. Okay? So let's try to move on. Okay, how many permutations? Okay, consider four letters A, B, C, and D. So we have 4 letters here. And how many possible permutation or arrangement can you have using 2 out of 4 letters? So we need to choose 2 out of 4 letters. So again, on the previous slide, N is the total number of selections. So this might be your N, and we will choose 2 of them. So that will be your R. Okay. So N, and we have R is equal to 2. Okay, so what are the possibles? So you have AB, BA, you can choose AC, CA, AD. Okay, there's a lot of possible permutation here or arrangement. Okay. I think that's it. 2, 4, 6, 8, 10, 12. So there are 12 possible arrangement or possible permutations for choosing 2 out of 4 letters in A, B, C, D. Okay. So here, let's move forward. Okay, so how about if I want to use 4 out of 4 letters? So consider the 4 letters, again the same letters actually here. We have A, B, C, and D, and how many possible permutation or arrangement of 4 letters can you have? So that means 4 letters, and we also use 4 letters at the same time. So N is probably 4, and R is also 4. Okay, so let's continue. So there's actually a lot too, right? So there's a lot of permutation. Okay, so there's a lot of possible combinations for choosing 4 out of 4 letters. Okay, so we actually have 1, 2, 3, 4, 5, 6, 8, 24. Okay, so let's try to move on to the formula. How to find the possible number of permutation. Oops. I lost my formula. Where's that? Okay, so actually the formula for permutation is N permutation R is equal to N factorial divided by N minus R factorial. Okay, so this is the permutation formula. Okay, so NPR is equal to N factorial divided by N minus R factorial. Okay, so let's go back with the first questions. Okay, so we have 5 letters. So do you remember the first slide that we have? So we have 5 letters A, B, C, D, and E. Okay, so we want to choose 3 out of 5. So we have N is equal to, how many options do we have? How many possible selections can we have? So we have 5 letters, and we want to choose only 3 out of 5. Okay, so let's try the formula. So N is 5P3 or PR. Okay, so is equal to N factorial. It is 5 factorial divided by N minus R. So 5 minus 3 factorial. Okay, so we will just try to simplify it. So if you can remember, this is in connection with our previous topic, which is all about simplifying factorials. Okay, so we have 5 factorial over 5 minus 3 factorial is 2 factorial. That will give us, so 5 times 4 times 3 factorial. Excuse me. I'll just write maybe below. So we have just 5 times 4 times 3 factorial. Or 3 times, times 2 factorial over 2 factorial. Okay, so you can just crush this out. So we have 5 times 4 times 3 is, okay, so 5 times 4 is 20. So we have 60. Okay, so we have 60 possible permutation for choosing 3 letters out of 5 in the letters A, B, C, D, and E. Okay. Okay, so let's try to move forward. I have a lot of examples for you later. Okay, so please bear in mind what is N and R. Okay, so let's try to move forward to some examples of permutation. Okay, selecting 3 items out of 5, out of set of 5. Okay, so this is actually what we did just now. So there are 5 letters and we selected 3. So, okay. Okay, so next, so how many unique ways can example number 1, how many unique ways are there to arrange the letters in the word iron? And let me bring it back. Okay, I'm not sure why isn't it the letters or the numbers are not appearing. So we have here how many unique ways are there to arrange the letters in the word iron. Okay, so in the word iron, how many letters do we have? Okay, how many letters do we have? So in the word we have actually, just make it a little bit bigger. Yeah. Okay. Okay. There you go. So, okay. So in the word iron, we have 1, 2, 3, 4. 4 letters. So, and how many unique ways are there to arrange the letters? So if we have 4 letters, so our N is equal to 4 here, and we want to arrange those letters. So how many do you think we're going to choose from these letters? Also 4, because we need to arrange the 4. So R is also equal to 4. Okay, so using the permutation formula, we have NPR is equal to N factorial over N minus R factorial. Okay, so simplifying it further, so we have 4 factorial or 4p4 is equal to 4 factorial divided by 4 minus 4. So remember, do you remember that 0 factorial is just 1, right? So 0 factorial is 1. So 4 factorial is 4 times 3 times 2 times 1. So this will give us 24 possible permutation or arrangement. Okay, so let me see if the next slide will be okay. Okay, so it's not viewing. It won't show. Still won't show. Okay, so I think that this is the versions are not compatible. So let me just use. Okay, so this one. Okay, I have here example number 2. Example number 2 is in how many ways a team of 12 basketball players need to choose a captain and co-captain. Okay, so there are 12 basketball players. Okay, so we have 12 basketball players to choose from. So that means our n is 12 here. Okay, so n is equal to 12 because there are 12 basketball players in total. So they need to choose a captain and a co-captain. So out of these 12 basketball players, they will choose 2 of them to be the captain and the co-captain. Okay, so R will be 2. Because out of those 12, we will just try to choose 2. Okay, so in how many ways or in how many permutation can we have? So again, go back to our formula. So we have n permutation r is equal to n factorial n minus r factorial. So we have 12p2 is equal to 12 factorial over 12 minus 2 factorial. Okay, so 12 minus 2. So simplifying it further, so you already know how to simplify it, right? So you can have just 12 times 11 times 10 factorials. So divided by 10 factorials. So you can just cancel it out. So you have 12 times 11, which will give us how many permutations? So yes, we have 132 possible permutation. Okay, so that's example number 2. So I prepared, I guess, at least 4 examples. Okay, so we have 10 students here. For example, number 3, have taken a test in which the top 3 will get different prizes. So there are 10 students to choose from. So we have n is equal to 10, and the top 3, so we have 3, will get different prizes. So out of those 10 students who took the test, the top 3 will get the 3 different prizes. Okay, so maybe the top 1 will get 1,000 baht, the top 2 will have 800, or the top 3 will be given 500 baht. Okay, so it doesn't really matter, but the top 3 will get different prizes. Okay, so we have from the 10 who joined the test, we have 3 of them will be chosen. So how many possible ways? Okay, so the same way. So we have the permutation formula. So we have 10 permutation 3, okay, is equal to 10 factorial over 10 minus 3 factorial, which gives us 7 factorial here. Simplifying it further, okay, so simplifying it further, we have 10 times 9 times 8 times 7 factorial over 7 factorial, cancel it out. So 10 times 9 times 8 thus will give us 720 possible arrangement or possible permutation. Okay, so one more example. I guess we need one more example for you guys. I will have you first here. Okay, so there are a total of 100 applicants. So maybe this is what you'll be doing. Okay, so when you finish your study, so you try to apply for a position. So there are 100 applicants applied for a position of manager. So there are 100 who applied to be a manager, site engineer, and a programmer. Okay, so how many applicants do we have? So we have a total of 100 applicants. So this will be our N, 100 applicants. And out of this 100, we are trying to choose 3. Okay? So those 3, one of them will be a manager, one of them will be a site engineer, and one of them will be a programmer. So that will make our R. Okay, so again, the same way or the same process. We just try to use the permutation formula. Okay, so we have 100 P3 is equal to 100 over 100 minus 3 factorial. So it's equal to 100 factorials over 97 factorials. Okay, so this is just 100 times 99 times 98 times 97 factorials divided by 97 factorials. Just 100 times 99 times 98. Thus will give us 970,200 possible permutations or arrangements. Okay, so actually, as this permutation is closely related or really similar actually to the fundamental counting principle. Okay, so we will talk about the comparison between the two in our next lesson. So if you have more questions, please always feel free to ask on our Google class. You can always send me a message if you have more questions about this. So see you later.